Welcome to the next episodes of the Full-Time GoDev program, and today we are starting a new chapter. Congrats to you. We are going to cover concurrency in Golang. Very important because concurrency in Golang is where the language really shines, right? Concurrency, distributed systems, asynchronous environment. That's basically why the language is designed and where it really shines. All right, so basically, the first thing we're actually going to cover is goroutines. It's very important. And what is a goroutine? A goroutine is basically a function that is getting scheduled by the Go scheduler, right? Golang has a scheduler in the runtime, right? Each time you build a binary, each time you build your own program, it's also going to build in, compile in the runtime, the Golang runtime. And in the Golang runtime, you have something what is called the scheduler. And what the scheduler will do, the scheduler will basically take all your goroutines and it will make sure that if a goroutine has no task to perform, it's going to schedule another goroutine. It's going to yield the processor and it's going to schedule something else, right? So you need to understand that goroutines do not run in parallel, right? There is no such thing as parallelism in Golang. It's concurrency, right? And I will give you a little bit more of examples on that because I think it's important to know, and it's not actually getting taught on the internet that much, or maybe not. Actually, completely not. So let's say, for example, let's make a function here. I'm going to make a function fetch resource or something, and we're going to return a string here. And what we're going to do is we're going to say time sleep, time second, 2 seconds maybe, right? That's what we're going to do. And we're going to return some resource, right? Actually, to be honest, some result, right? So it's very simple. This is a function, and that function will return a string. But first of all, we're going to sleep 2 seconds, and then we're going to return some result, right? So it's very simple. We could say, for example, a result here in main is going to be fetch resource. And let's print out when it's done the result, right? We're going to say here the result is this result, right? So if we run this, you can see that we are waiting, right? I'm going to do it again. You can see that we are not instantly returning some result. We are basically sleeping 2 seconds, right? And you can imagine that if you have, for example, let's delete this. Actually, to be honest, we can keep that in. Let's comment this out like this. And we're going to say fetch resource here. And we're going to copy that a couple times, right? Maybe you're going to have some computations, and all these computations will take in, for example, you're doing HTTP calls to a third library or to Stripe or to whatever. You're going to fetch some APIs, third-party APIs, and you're basically going to put them under each other. So what's going to happen is that we're going to wait a very long time, right? Because we first need to fetch resource 1, then we need to fetch resource 2, then we need to fetch resource 3, and so on and so on and so on. And you see that the program is still running, and finally it basically completes. And that's because all these operations, all these functions, they will take 2 seconds, right? So how can we turn this fetch resource into a goroutine? It's very simple. The only thing we need to do is basically prepend go. That's the only thing. And that's a syntax, right? You prepend, it's prepend. You prefix basically go keyword before your function, and that will basically tell Golang that fetch resource right now is going to get scheduled somewhere else as a goroutine. And that basically means that if we go run main.go once again, you can see it instantly completes, right? Because this is going to be an async call, right? It's going to be an async call. That does not mean that if we are here, right, that fetch resource is already completed. No, that's not true. Fetch resource, it's the same thing like in Node. It's a non-blocking call, right? But that does not mean that if we are here, that fetch resource is completed, is resolved, right? Very important to know. How can we also make a goroutine? Well, we could also do something like this. We could say go func, right? Like this, go func. That's basically schedule an anonymous function, schedule an anonymous function, oh my god, this word, in a separate goroutine, right? And what we could do here is also do fetch resource, right? It's the same concept, right? It's the same concept, right? You could either do this syntax, or we could do fetch resource this syntax. It's actually completely the same, right? Of course, you can already see that we have some troubles, right? And what is the problem here? Well, the problem is that we do go before our fetch resource, but fetch resource is returning a string. So how the hell are we going to get our result here, right? And we're going to even make this fetch resource a little bit better. We're going to say fetch resource, let's say n is going to be an int. And then we're going to say here, we're going to say a result like this, underscore maybe. And then we're going to say plus, actually we need to convert that to a string. So we're actually going to return here fmt s printf. And we are going to return a result percentage %d. And that's going to be n. Right? Why are we going to do that? Because then we can do something like this. For example, let's bring this back to life. And we're going to say fetch resource 1, for example. And if we run that, then we're going to get the result is result 1, right? So now we can actually do, we're going to use that, right? So we can see what result we get, right? Because otherwise it's always the same result, and that's not ideal. So the problem is going to be, let's delete this shenanigans here. The problem is that if we want to fetch, if we want to make a goroutine of fetch resource, the problem is, of 1 for example, how are we going to get a result, right? You could say, yeah, but we could do go func, for example, something like that, right? And then we're going to say that the result here is going to be fetch resource 1, and then we're going to say fmt println the result. Right? That's not going to work, right? Look at this. I'm going to show you this. Boom. And where is my print line? It's nowhere. That's because, remember what I told you, that go func, everything where go is being prefixed is going to run asynchronous, non-blocking into another, so to say, thread, green thread, if you wanna call it that way. So even if we are here, that doesn't mean that this function is resolved, right? So, how are we going to do that? Well, that's where channels come into play. So basically, what is a channel? And I think maybe I should do channel in another video, but this is fine. Let's do it in here, and we could make another video where we're going to do a deep dive. This is basically more an introduction then, right? Goroutines and channels. So what is a channel? A channel is basically, you can think about channels as some kind of a mailbox of a pipe, right? Where you can put things into the pipe, and on the other side of, a tunnel. A tunnel is better, right? Think about channels as a tunnel. There is a tunnel, and you can put things into the tunnel, and people on the other side of the tunnel will receive what you put into the tunnel. That's what channels are, right? It's kind of a way of communicating, right? It's some kind of a queue, a tunnel, a pipe, whatever you want to call it, right? So how do we make a channel? Well, that's very simple. Let's going to delete this cofunc because we're going to cover channels right now. So we can declare a channel, for example, result channel. And it's a very common practice that you basically append ch at the end of your variable if you want to declare variables, if you want to declare channels, because then everybody knows, oh, this result, for example, if you say the result is going to be 10, for example, then result could be anything, right? If you see result here, for example, and you read this result into another function, you're going to see, okay, it's result. It could be some result, maybe a struct, maybe a string. But if you say result channel like this, or maybe like this. I like it like this. You could say, we know that if we use result channel somewhere else in a function, you can directly see, oh, this result is actually a channel, right? If that makes sense. So this result channel, how do we make a channel? It's very simple. We're going to say make me a channel, chen, and then we're going to say the type of the channel. And in this case, for example, it's going to be a string, right? And then we can specify the buffer of the channel. But that's something we're not going to cover yet, right? Let's keep it very simple for now. So it's very simple. We're going to say make me a channel of this type, right? It could be a channel of integers, it could be a channel of float 64s, it could be a channel of a struct, for example, type foo struct, like this, right? And then we could say make me a channel of foo, right? You could easily say, hey, make me a channel of pointers to foo, right? You could make a channel of any fucking type there is on the planet, even your custom types, right? So, but we're going to say make a channel of string. So, what can we do with a channel? Well, we can, like I said, a channel is a tunnel or a pipe, and we can put values inside of that tunnel. How do we do that? Well, the syntax, therefore, is result channel, and then we can use this arrow operation, and you see, the arrow points to the variable. That basically means write things into that channel, and we're going to say, for example, foo, right? So right now, we're going to write. Think about writing and reading. People putting things into the tunnel they are writing to the channel, and people reading, extracting values, or basically on the other side of the tunnel, are basically reading from a channel, right? So that's result channel. And that's how you basically put values inside of that. So how can we actually read values from a channel? Well, we could say, for example, that the result itself, res, for example, or result, is going to be result channel, right? It's the same thing, right? Now we are basically writing foo into that channel, and now we are basically reading from the result channel into our variable, right? And if you print out, for example, here, print ln result, what's going on? Undeclared name result. Oh yeah, that's true. We are actually wrong. We need to do it like that. My bad, right? So if you want to basically read, then you need to assign your variable naming, and then you're basically going to read from a result channel. And the result will be basically what we put into our channel, right? And this is going to cause some issues, but it is what it is. Like you see, all goroutines are asleep at deadlock. I already knew this up front, and you probably will encounter this issue also, and that's why I basically just let it happen so you can see what this is, because it's very important we cover this. So what's happening is that all goroutines are asleep. We have a deadlock, right? And the reason why this is actually happening is because you have two types of channels, right? You have the unbuffered channel, channel, and we have the buffered channel, right? And this is basically an unbuffered channel, right? Why is this unbuffered? Because there is no buffer, right? It's an unbuffered channel, and you need to understand that an unbuffered channel always blocks, actually, to be honest, a channel. This is very important. Note this on a piece of paper right now. Take a piece of paper, open up a text editor, open up your notes. I don't care. Write it on your hand or on the boobs of your girlfriend. It doesn't really matter. But a channel in Golang will always block if it's full. I'm going to repeat that. A channel in Golang, if it's buffered or unbuffered, is always going to block if it's full. And what do I mean by if it's full? This is an unbuffered channel. If we copy this and we do this, for example, this is a buffer channel. What is the buffer size? 10. Easy. And that basically means that you need to think about, and I already made a video on YouTube about this, you need to think about a channel also as a box. And inside that box, you can place cookies. But an unbuffered channel, we have no box. There is no concept of a box. In this buffered channel, we have place for 10 cookies. That basically means that this buffered channel is a box where inside of that box, it fits exactly for 10 cookies. That basically means it fits for exactly 10 strings in our case. And what did I told you? That if there are 10 cookies or 10 strings in our box, the channel is going to be full. That basically means what I told you before, and I'm going to repeat it once again, that a channel will always block if it's full. So that basically means that if we have 10 cookies here, it's going to block. This has no box. You need to pass the cookie directly over the tunnel. There is no box. You cannot put it in a box. There is no place to store the cookie. That basically means that the moment we are going to write foo inside of this result channel, what's going to happen the moment we do this if there is no box? Exactly. This is now full. And what did I told you? Once again, this is so important concept, guys. This is so important to understand. It will block. Why? Because it's full. Because a channel will always block when it's full. That basically means that if we block here, we block here, that basically means that this code below will never execute. Why? Because we are blocking here. Why? Because we just wrote to the channel, we just filled up. So we block. How can we solve that? We can solve that by either buffering the channel. For example, I'm going to buffer it with 1. And it works perfectly fine. We get foo, which is basically the value we wrote into the channel. If we delete the buffer, if we don't make it the concept of a box, it will block because we wrote to it. You see, goroutines are asleep. How can we solve that? Well, what we could do is basically, because this code, the code below this, it will block. How can we make it unblock? Well, that's going to say we're going to make a goroutine here, gofunc, right? And inside of this gofunc, that basically means that this will never block, right? It's a go function. It will get scheduled. It's non-blocking, right? So we could say that we're basically going to read the value of the channel inside of a goroutine here, right? So we spin up another goroutine where we are going to read from a channel, and here we are going to write into that channel, and it's unbuffered. That should work, or not. It works, right? You see? So basically, but you need to be careful because in this case it's going to work because it's super fast. But we are making this in a goroutine here, right? But it's fine. Don't worry about it, right? So this works. Why does it work? Because we basically unblock it here, and then we write, right? You need to think about it before you can give a cookie to somebody, right? Let's say I have a cookie, and there are other people that basically willing to give me more cookies, but I cannot accept a cookie from these other people because I still have a cookie in my hand. And how can I release this cookie? Well, I could put the cookie into the cookie box. If it's a buffer channel, I can just put my cookie into the cookie box. But this is an unbuffered channel, and what I told you, in an unbuffered channel, we basically do not have the concept of a cookie box. So I cannot put the cookie into the cookie box. So what can I do? The only thing I can do is give the cookie to somebody else. But if there is nobody else, right? in the previous case, where we first wrote into the result channel, it blocks because there is nobody to give a cookie because I'm blocking, and people are willing to give me a cookie, but I cannot accept a cookie because I still have a cookie in my hand. I don't have a box, and there is nobody to give a cookie. So I'm basically blocking here. I'm sitting here with this fucking cookie, and I cannot even eat it, and I'm hungry, right? That's the thing. But if, in this case, there is a gofunc, right? We first make it possible to accept a cookie. That basically means that there is somebody to accept a cookie. And then somebody gives us a cookie, that's perfectly fine, because I can give that cookie directly to the other person. Because there is one. It maybe sounds complex, but if you think about it, it's, in my opinion, one of the most easiest way to explain you these concepts, right? So I'm going to leave it for this introduction in concurrency goroutines channels for this, because there is a lot of stuff we need to cover. So it's going to be a multi-video chapter, right? This concurrency and goal. It's very, very important. It's so important. So we're going to spend some time in this. But this is basically giving you what are goroutines, what are channels, how to write to a channel, how to read to a channel, buffered, unbuffered, and what can happen, right? And in the next video, we are going to dive a little bit more deeper into these concepts. All right, see you soon.